Hi everyone, this is Lady Emmanuel coming to you with Graph and Quadratic Function Activity 30. It's a review for all three lessons that we have done for transformation, the translation one, the stretching and the string one, and the multiple transformation. When you make sure you write your answer on notebook paper, show your word. For each quadratic function, is to describe the transformation of its graph from the graph of the parent function, and this is the quadratic. Guys, you should know all the information for quadratic first in the vertex, the domain, the range, and the axis symmetry. So here for the parent function, and I'm going to write it down here, do a little review for you. The parent function, the vertex would be your lovely 0, 0. It's a minimum because it's open upward, okay? The minimum value is 0. I'm put min value. It's 0. So from the vertex, you can give me the domain, for the range, but let's do domain. Domain for parabola's quadratic function at least, the domain will be all real numbers. You could just write out all real numbers because if it's open upward, I discussed that in the other videos with you. The range, since it's a minimal, it's going to be y is greater than equals to whatever the y value is in the vertex. So in this case, the y value in the vertex is 0, so it'll be y is greater than equals to 0. The axis of symmetry for the parent function is the x is 0. For any quadratic function, the axis of symmetry is the x value of the vertex. So it's going to be x equals to 0. That will be that vertical line. Okay. So here we go. If you look at number 1, guys, you see that this is the parent function. The only thing being done to this parent function is 7 is being added to it. Okay, meaning that it's being shifted up. Okay, that's the only thing. Here's the parent function. What is being done to it? Something is being subtracted from it. Okay, so when nothing is being done but add or subtract, you either move up or down. Nothing has changed with that parent function. 3 and 4, you notice that it's a little different because of you're doing something to the x first before it's being squared. So that means that I'm not shifting up or down. It's not a vertical movement. It's a horizontal movement, okay? So here, I know that it's moving to the left. Here, it's moving to the right. You may, if you're doing this class, use a calculator. Or at home, Google a graph calculator, and you'll see what I'm saying, okay? Number 5, it says, the graph of which of the following has a vertex at 0.08. Think about it. Here's your parent function. Parent function, nothing being done. So if nothing is being done but it's moving up or down, then the only thing is changing of your vertex is going to be your y value. Here, it's being shifted left and right, meaning the x value of the vertex is being changed. The x value is being changed, not the y value. So the y value stays the same. Okay. So I'm not going to tell you that. If you listen, you'll catch it. Okay, I need you to think. I don't want to just point everything out to you. Okay, use your calculator, you'll catch it. Listen to it again. It's to identify the range of the function y equals x squared minus 3. Okay, the range. What is the vertex? If you know the vertex, and you see this positive, so it's going to be open upward, so I know the range is going to be y is greater than equals to whatever the y value is for that vertex. Okay. 7 says determine the equation of the axis of symmetry of the graph of y equals x squared minus 3. This is the same as number 6. It's the same function. Okay. Again, if you know the vertex, then you know that the x value of the vertex is the axis of symmetry. So you know to write x equals whatever the x value is of that vertex. Number 89 has the same function. Here, you're identifying the range, meaning you're saying y is greater than or equals because this is positive. Okay. Here, and the y is greater than or equals to whatever the y value is for the vertex. 9. Here it's talking about the axis of symmetry. So it's going to be x equals whatever the x value is of the vertex. Number 10, It said write the equation of each quadratic function. Guys, you may need to go back and look at the, for this one, go back and look at the video that I worked out. I showed you how to determine A, and from there we got the equation. B says the quadratic function whose graph is translated 10 units to the left from the graph of the parent function. So this one, I know that is this function, guys, is going to look something like number 3 on here, okay? Because this is going 10 units to the left. So it's just one thing would change in this equation here to make the equation for B. See, you can really hear, bam, bam. I know this right here is my vertex. So I can determine what my A is just like I would do for 10 and solve. Okay, look at the other videos. Going over to number 11. The graph of which function shares a vertex with the graph of y equals 5x squared plus 3. So determine what's the vertex of this. Once you determine the vertex of this, when this function, 5x squared plus 3, then determine the vertex of these, and you will have the correct one. Okay? Identify the transformation. Come on, people. I'm not going to read the rest of this for you, but just read it and think about the previous lesson. Think about it and complete what it says. Just respond, but you got to read it. If you read this and just take your time, guys, I know you could do it. You may have to review some videos, but you can do it. Okay? It's really fun. It's fun. Math is fun. It's just, to me, it's the same thing over and over. And what we do, we just make it look more challenging. And I love it. Because it becomes a game. It's like, I'm going to break it. I'm going to break this code or what have you. I can do it. Love you guys. Peace out. Be blessed.